Good morning, everyone. Welcome to Check 2020. My name is Cole Kelley. I'm from Emporia State University. If you have any questions for today's session, be sure to submit those through the Submit a Question button on the page for this session. This session is the AWS Technical Deep Dive after going through AWS Preserve Migration Readiness Planning Process with Don Eisele from Kansas State University. And with that, Don, I'm going to turn it over to you.
Hello, I'm Don Eisele. So my group has been on AWS for 7 years, and we recently went through the AWS Migration Readiness Program. And through that, we designed a new account structure for Amazon that we're going to be looking at today. Let me share my screen here. All right. So overview of the things I'm covering today. I'm going to be trying to cover a lot of material, so I'm going to go through fairly quickly, and so we can have some time for questions at the end. I'm going to briefly touch on the MRP and what it is. I'm going to go over the well-architected 5 pillars for about 20 seconds. And then I've got some different categories that I'm going to be talking about. Sorry, I've got killed this. All right. The organizations and multi-account structure, operations, security, and cost optimization. So the K-State MRP, if you saw the previous talk, Amanda covered the MRP process that we went through. What I'm talking about today covers what the MRP process with AWS created. We created new accounts with a new structure. We did have a previous structure as well, but we went ahead and we're going to be moving that stuff over and migrating it instead of and we have been doing that instead of trying to upgrade our current account into that structure. We just created something new, migrated the old stuff in. So the AWS Well-Architected 5 pillars are AWS's ways to create a good architecture. Sorry, I got a chat that just won't die. All right. Following those pillars are what really directs you to a better, well-architected AWS environment. And you really need to understand those if you want to have a good product in the end, an environment you can use well, and it does all the things you need to do securely and reliability. Those are operational excellence, security, reliability, performance efficiency, and cost optimization. Those are well documented. I'll leave it up to you to go look at that if you haven't already or aren't familiar. But definitely take a look if you haven't. And if you're an Azure person or a Google person, these apply to every cloud experience and not just AWS. So it's a good resource for everyone. So organizations. Organizations is a way to set up a multi-account structure where you've got a root account and then other accounts beneath that are part of that structure. In that, you create organizational units that you can have different accounts in, and each of those organizational units can get security control policies or policies that allow or disallow and set some basic guardrails for that account so that it may or may not be able to do things. For instance, we've got some accounts that don't need network access. So in their security control policy, creating a VPC is disallowed. But other ones have other stuff like, you know, the obviously the ones where we got workloads, you want the VPCs, so that is allowed. So it really lets you set the guardrails so that the accounts are functioning the way you want them to. Control tower and landing zone are ways to manage those multiple accounts and keep a consistent environment in them that has all of your logins the same and all of this stuff consistently across all the accounts, so that they all work together seamlessly, and you don't have to spend a lot of time managing the accounts. And then networking of this, each account that needs networking has one VPC. Each of those VPCs has 2 subnets, and those subnets are in different availability zones. So basically, when you spin up a resource you want to be highly available, you put it in 2 different subnets, and those are in different availability zones, which equates to different data centers effectively, so that if one goes down, you're still up and running on the other one. And that way, we've designed that in to keep that function going. And then we have a transit gateway that runs in our transit account, and that's actually the core. We've got a hub and spoke model for the networking, so that everything goes through the transit gateway, and the talk between the different accounts is through the transit gateway, and the talk back to campus is also through the transit gateway. For the account structure, here's basically what we got. I simplified a little bit. There's a couple other things, like if we wanted to add a department, we could add another department and maybe put it under its own OU. But the root account sits above everything. All of the other accounts are in an OU, getting SCPs from the root account. You can see that our prod, dev, and sandbox, those are where our major workloads are running. They're in one OU, and that they get the policies that are like a workload account. And then our shared accounts, basically shared services, where you've got DNS and directory services and that sort of stuff. And then our transit account that does all of the routing are in a shared OU. And then the core OU is more restrictive. This is where our auditing and security log archives and whatnot go. And that's mostly setting things to be kind of read-only, so that we can't go in and be destructive there, because we want those things to be immutable. The reason for separating all these accounts is one of blast radius, and I'll talk about that later. Control tower and landing zone. This is landing zone was something that's been around a little bit longer than control tower. Control tower is basically a newer way of that they released right as we were in the middle of this, so we were one of the first customers to do it. And it's just basically a set of tools to help you manage these multiple accounts. So we've got control tower pushing stack sets, which are a CloudFormation thing, and service catalog entries to all of the other accounts. So you have a consistent baseline, the account baseline, security baseline, network baseline between the different accounts, so that they're all operating independently. One of the things that's pushed is like our SSO configuration is pushed down to all the accounts through this. The transit configuration, so that all the accounts talk to the transit account, is pushed down through this. And here's a kind of a diagram of how the transit gateway works. We've got VPN and backup VPN back to campus. It goes to our transit account, and then through the transit gateway, it goes to the other accounts that need networking. Notice the root, log archive, and audit accounts don't have any networking. They don't need it. We just access them through the console only. Operations. We're going to talk about automation, service catalog, the golden AMI, tagging, and managed services. So with automation, CloudFormation is your major workhorse here. It provides common language, models, resources in Amazon. So when we execute a CloudFormation script, it can spin up EC2 instances, load balancers, networking, security groups. It can fire up RDS instances. It can do all of the different things we want to fire up, and you fire it up, and then it creates these resources and puts them in your environment. One of the things it does lack is it doesn't really have any version control natively. So we want to keep our CloudFormation scripts in Git, so we can see when they're changing and why, and we can link those back to problems or improvement. And so with that, we're using Code Pipeline as a continuous delivery agent to automate getting those from Git into our AWS environment. It automates their build, test, and deploy. So you can have it stuff things into Service Catalog or directly execute CloudFormations. Then Lambda, which is a serverless computing, in addition to writing applications there, you can just write pieces of code that do work in Amazon. So if there's some piece of glue that doesn't exist between two different services, or some automation, something you want to happen on an interval or a particular time, and in AWS doesn't have direct hooks to do it, they provide hooks that you can talk to Lambda, and you can write actual code to do that service, and that makes all of the AWS services infinitely configurable. Here's an example of a CloudFormation excerpt. It's creating an EC2 instance in a security group and applying it to that EC2 instance. It takes parameters that are going to be specified elsewhere in the file. Here's a code pipeline. You can see that it goes through, it's got a source stage and then a build stage, and then it goes through the deploy, execute, sandbox. And you can see if it fails on any one of these stages, it's not going to go further. So at the very bottom of this, you see it hits the sandbox first. And if that fails, it's not going to go any further. But only if it succeeds is it going to go into shared and prod, because you don't want to put something in prod that's going to break. So if we got our tests in there, we can also put a manual step in between the sandbox and deploying the shared or prod, to where we have to click OK. We've tested it in sandbox. We're OK for this to proceed up the line. And this is an example of some Lambda code. This is our scheduler for shutting down EC2 instances that are in sandbox. We shut them down every night because we don't need them on overnight, and it saves us money. The service catalog is a catalog of standard services, and it's basically a set of CloudFormation scripts that individuals can come in and just with a few clicks, they can execute this CloudFormation. It does it under an assumed role, so they don't have to have the privileges that the CloudFormation normally requires. And those CloudFormations can be set up to be standardized, so we're doing things consistently. This really makes it easier for the people who aren't programmers and programming CloudFormation to be able to execute stuff and have things that can get cleaned up automatically by destroying the CloudFormation and not leave junk all over the account. And everything then is more standard, has the required tags that we want, and all of that other stuff. Here's a view of that service catalog page. You just click on any one of these things and then click launch, answer a few questions for required information, and it's up and going. Golden AMI image is a custom image that contains all of the security patches, software configurations, antivirus, logging agent, everything that you want as an organization to have, and you want it everywhere. So instead of someone spinning up an instance and then having to go through all this stuff by hand, or every single script, CloudFormation script out there doing the same stuff, you can create an AMI that has all this baked in already. Our process uses Code Pipeline, CloudFormation, Lambda, and Systems Manager to build those. Here's an example of the Systems Manager document that actually builds the Golden AMI, starts the instances, installs the different things in different steps, and then later on it's going to stop the instance and then build an image from it, assuming all of the build steps were successful. Tagging is critical. You really need to think about your tagging policies. If you don't do this, it's going to become the Wild West and become spaghetti at some point. So there's several things you really need to look at: the technical aspects of tagging, any automation things, business needs, and security. So here's kind of a view from our wiki of all of the tags we currently have. A lot of them are business driven, like the customer, the owner, which group actually owns that resource. And then there's also like backup stuff for automating backups and different things. So all of these things are in there. There's a technical contact, so you know who to call if you see problems with particular instances, and notify them. So I know you can't see this very well, but I'm just showing that there's a lot of stuff. If anyone needs more information on this, feel free to reach out. Managed services. We generally try to prefer managed services if we can. It reduces the administrative overhead and it lets your technical people work on making better and more reliable services. So they're not spending their time managing disk space or all those other things that can be automated, and like applying patches even. Like, so RDS is patched automatically. You set it, when patch is available, it lets you know, and then you can schedule when you want that to happen, and normally it's silent and you don't even have to be awake. You can do it in the middle of the night. It is a work in progress because it is a lot of work to take one application and break it up into all the different managed services that you can. So take the easy wins first. RDS is a pretty easy win. You can export your databases, import them to RDS, just change your connection strings, host and port that you're connecting to, and it's pretty painless on that. So it's a easy win. We're running most of our databases on RDS now, but we're working on moving more stuff over time. Earlier in 2020, there were over 212 managed services. So there's a lot of stuff out there. It can be overwhelming. Don't worry about everything at first. Pick the big ones and go with them. Start on them, learn them, do them. And then as time moves on, you can add more and more things. Next, I'm going to talk about security. In security, we're going to talk about blast radius, single sign-on, auditing and logging, and WAFs. So the blast radius is all about our multiple account setup. So when we are looking at our multiple accounts, the reason we have the multiple accounts is like we don't want someone in Sandbox accidentally doing something that ends up affecting our production load. We don't want something going awry in test or dev that affects our production load. We don't want something in our Sandbox to take out our networking, which runs through our transit account. That's why the transit gateway is in the transit account. It's very separate because that's very critical to the entire structure that we have. So it's just creating that blast radius that one thing can't take out another. The second part of that is that because we're using CloudFormation scripts, we can develop our resources in Sandbox, then test them in our dev environment before promoting them to prod. So we since CloudFormation, we can test them exactly as they were tested in the previous environments, and there's not any real human error of like, oh, you forgot one step in your list of steps to do as you're spinning up a machine. So that really lets stuff be vetted before it hits prod. Then within each account, you have security groups, and security groups create a safety fence to keep applications from interfering with each other. So these are basically like microsegmented firewall rules. And so you just really don't allow the applications to talk to each other. And this works really well. You can automate when you've got another group you need to talk to. You can symbolically address its security group by name instead of by IP address. So as things dynamically change, it will keep up and automatically rebalance and keep up with all of the changes. So that's very handy. Single sign-on. We set up single sign-on so we can use our existing federated logins on campus and map existing users to specific roles and specific accounts. This lets us create, it lets us use our multi-factor authentication that we've already got in place, so people don't have to do something new using the same user and password. And it lets us have a high granularity of controlling what people can have access to, because you can set up multiple roles in the account, and people can be in multiple roles or in multiple accounts. So it's very much controlled with that. It also helps us so that you actually have to log in separately to test and prod, but it's still using the same credentials, so it's not a super hassle, but it just creates that consistent environment that we're doing, but also still keeps up with that segregation for the blast radius. Auditing and logging. Auditing and logging get copied to separate accounts. The reason for this is because those accounts, we can set the roles on them pretty much read-only review, so you can't go in and modify logs. So they become unchangeable, immutable, and they're there for review, and we can't. And so it makes it harder for any sort of problems if we do have problems to cover tracks or accidental deleting or something like that. Those accounts don't have VPCs, so it prevents lateral movement from the actual production loads. We still have access through the AWS console, and that access, you actually have to be able to look at logs for them to be useful. We're using Security Hub and Guard Duty to summarize security issues with low, medium, high. That really helps you pick through, so you're not waiting, you're not trying to read logs. There's enough stuff that you can't just go read logs. It's not gonna be effective. But Security Hub and Guard Duty are built into AWS. Eventually we might get to a full SIM product, but these provide some basics, and you can also provide more hooks into them for other specifics if they don't have a hook already. So here's an example of Security Hub. Basically, this example is showing where there was a machine that was allowing RDP and SSH in from the world, which normally you're like, man, why do we want RDP and SSH to the world? It turns out in this case, looking at the details, it was on a private subnet, so it wasn't actually open to the world. So it wasn't a real problem, but it was something that pointed out a problem that we should probably look into and make sure that someone hasn't done that accidentally and opened up something that really shouldn't be opened up. Here in Guard Duty, we're looking at, on this one, it shows these recon AMI user permissions. So in this case, it's someone was going and looking at a role to see what it could do, which we kind of expect right now because we've still got a lot of people who are learning. So that's definitely something that we expect right now. So again, not a particular problem at the current time, but as things get more mature, if we see not very many of those and all of a sudden we get an explosion, we should probably check it out and see why there's more of it. Is someone gotten in somehow and is looking to try to get in deeper into the system? Web application firewalls automatically block common exploits, SQL injection, cross-site scripting, etc. You can also make, if you're encountering a DDoS, you can put rules in there. And so the WAFs are operating further away from your application and closer to the edges of the AWS infrastructure. So if you put DDoS rules into your WAFs, it will keep things from even entering your VPCs and clogging up any sort of limitations you have there. So they really protect you and insulate you. Always be sure to test these before turning them on. We had some issues early on where we found out that some of the default cross-site stuff was blocking SOAP requests because it didn't like the XML format that was there. It was processing that as HTML, which doesn't allow some things that are allowed in XML. So we had to put some exceptions for those things that were doing SOAP for that one particular thing. Shield Advanced goes up above and beyond the WAFs, although it's a little bit pricey. But it also makes WAFs free. So when we get enough WAFs that we start in that cost, we can switch to Shield Advanced and get even more DDoS protection. But we're not quite there yet. Cost optimization. So when we're going to cloud, the big scary thing is like, well, how much is this going to cost? And to some extent, it's really hard to estimate stuff, and it's really easy to make mistakes and for that cost to explode. Early on, we had some things in our backup system that was going to S3 that was doing a comparison, and cost us $6,000 in like a week and a half or something like that, 2 weeks. Because it was actually every night it was comparing and downloading everything from S3 and comparing it every night. And that wasn't good. So to do that cost optimization, first thing is automate stuff. You know, if you're doing stuff manually, you're much more likely to make error. Automation reduces administrative overhead, spin up and down resources, gives you time to go check on things. Code pipeline, CloudFormation, Lambda service catalog will help that. Also allows self-service, so your devs can spin up their own stuff, but still keep it constrained, and let your admins go do other stuff like check and make sure that everything's going okay. Auto-scaling is also very important, and with auto-scaling, you can use services that scale dynamically based on demand. So at the beginning and in the semesters, those are things that we all have to deal with. It can automatically, as the load is spiking, spin up more resources to let that happen. Now, with auto scaling, things need to be stateless, so that's something to keep into account. But it's still very powerful, and that you can really save a lot of money. There's also reserved and savings plans. The savings plan is a little newer than reserved, and it probably is better than reserved because it's a similar savings, and you don't have to apply it to specific resources. You just say, here's my EC2 spend. I'm going to guarantee I'm going to spend this much money. And then then if you're switching instances around, it still works. And as you grow, you just start adding more money to your savings plan. So now note that with auto scaling going up and down, you're not going to get savings plans on the additional stuff that you're spinning up and down that's not necessarily on all the time, but it can't save as much as something that's being off most of the time. So auto scaling still saves you more money. And scheduling is another way to save more money too. Just shut off things you're not using overnight, and that's going to be automated with Lambda, and like just shut down everything after 7 that's not tagged please leave me up. We're not doing this in prod, of course, because we expect prod resources to kind of be in use, but on our dev and test and our sandbox, we at 7 we shut things down, and that saves us, that gives you a 50% utility cycle. And if the dev doesn't turn it back on the next day, although we can have a tag to automatically turn stuff on, maybe saving even more than 50%. One thing that I forgot to mention in this slide is Trusted Advisor. Trusted Advisor also has some stuff that you can go in, and it will give you some recommendations on sizing and various other things. And it helps with your cost optimization too. It's got good recommendations there. So here's an example of auto scaling. You can see the min, desired, and max are the 3 things you specify in auto scaling. And then the rest of the stuff scales on demand as the demand goes up and down. And so the max is what you're typically going to be paying, and you only have to pay for the extra for the times it is actually in use. Here's an example of some results from our scheduler. This is from our sandbox account. There's a lot of accounts that are just not in use, and they were probably stopped automatically by the scheduler. And so the people can spin them up when they need them again. All right, I have some time for questions now. Hopefully that wasn't too quick and you got something out of it, but if you have any questions, now is the time. There is a Google form both in the session on the website and also in the YouTube channel.
Thank you for the presentation, Don. I'm looking at our sheet here. Let me just refresh just to be sure. As of right now, I'm not seeing any questions. Sam, if you would mind just confirming that for me. Okay.
Also, if anyone has any questions later on, feel free to reach out and contact me. My email is my last name at KSU.edu. And I'm always happy to answer questions and give more detail on some of these things.
Well, in the absence of any questions here, is there any final remarks or anything else you'd like to talk about?
So one of the things that I'd like to point out is Amazon is got really good support. When you're in the AWS Inventory, they were great to work with. They really helped us make these decisions. They didn't just say, here, whatever, just do it. They were like, they presented options and they were like, here's different things you can do. They talked to us and we actually worked together to produce this. So it wasn't a one size fits all. It was very customized to us and what we were doing. And with that, we were able to get our feet wet in the planning stage. So we weren't just like very confused at the end and like, what's going on? So we actually were part of that planning process. So we were able to really understand what we did. When we went to deploy stuff in the environment, we did it and they looked over our shoulders for like the control tower and things. So it was very helpful. And so we have a good understanding of our environment. And then as an ongoing operational perspective, AWS support is really responsive. So the basic support, there's different levels of support. In the I think it's the business support where you get the chat. That one is super responsive. It's great. In general, AWS support goes above and beyond what they've agreed to do. So you will get not just answering the question, but they'll point you to the documentation and they'll give you maybe some gotchas or caveats or something like that. And they'll say, hey, be sure to think about this. And it's really better support than we see from most tech companies. So very much, if you're having a problem, open a ticket. It doesn't cost you anything. Just open a ticket and really talk to support. And they're super helpful. It's really great. We've had really good experience with their support and with the MRP. So it was a very good experience. So I highly recommend reaching out to Amazon if you're running into things.
Great. Well, thank you, Don. It doesn't look like we have had any additional questions come in. So I just wanted to thank you for your presentation. Thank you for everyone that's tuned in and has shared this with us today. And we'll see you in the next session.
Thanks.
Mm-hmm.